At some point in our life, we all have typed the website URL into our browser, hit enter, and watch the whole page load in an instant. It feels like magic. But behind that single keystroke is a high speed, invisible game of telephone happening across thousands of miles. So, if you're leveling up in system design, understanding this journey isn't just trivia. It's the foundation of how every app, every database, and every distributed system survives at scale. So, hi, my name is Anubhav and I'm a senior software developer, and today we are going to break down exactly what happens in background without getting lost in a boring 500-page textbook. So, computer talk in raw electricity, ones and zeros. So, if we had to manually code how those signals travel through cables every time we want to load a page, we will all go mad. That's why networking is built on layers. Think of it like ordering food on an app. You don't need to know how to bake the pizza or how the delivery driver's motorcycle engine works. You just interact with the app layer and trust the layers beneath you to handle the heavy lifting. In system design, we focus on three main layers. So let's trace what happens when you type youtube.com. So your computer doesn't know where is youtube.com. It only speaks in IP addresses, numbers like this. So your browser checks the DNS, our giant digital phone book, to translate that name into a physical server coordinate. Your browser doesn't just start streaming data. It's polite. It initiates a three-way handshake first. Your computer sends a synchronous packet, hey, can we talk? The server replies with a synchronous acknowledgement, yes, let's talk. And your computer confirms back with an acknowledgement and say, okay, the connection is locked. Now that a secure lane is open, your browser sends an HTTP GET request and asks, okay, give me the page. The server processes the request and streams the data back. This is the latency most developers think about, but it's only one part of the story. Once the data is delivered, the connection doesn't just snap. They politely break up using a four-way technique. Now, why does this matter to us? There are two big reasons. First, latency. Every handshake takes time. So when you scale to millions of users, repeating this setup for every single request becomes a massive performance bottleneck. Second is the state. Keeping these connections open requires large memory on both the client side and the server. So that's it for this video. And in our next video, we are going to look at what happens when you strip away all that safety baggage and why some high performance systems throw the rulebook out of the window just to use a protocol called UDP. So make sure to check out part 2 of this networking series. And if this clicked for you, hit like, share it with your developer friends, and subscribe to DevNotes.io so you don't miss the next deep dive. Till then, signing off.